Section 5.6, logarithmic and exponential functions. So there's nothing new going on in section 5.6. That's a lovely thing, with the exception of this one tiny little property right here. And I want you to notice it because this is really actually very cool. What this says is that if I can create a situation where log base a of some argument equals log base a of another argument, then the two arguments are equal to each other. We always have to assume when we're working with this that the arguments have to be positive, the base has to be positive, and the base cannot equal 1. All right? Now remember, the argument always has to be, our domain restriction is that the argument has to be greater than 0, so that makes they're positive, but then the base cannot be the number 1. Okay, so let's take a look at this problem. We have two bases. They are equivalent bases. If this number 2 was gone right there, we could use this property and say that 4 equals whatever we have for this argument. The problem is that 2. So think back to section 5.5. What did we do with that 2? Well, we throw it up as an exponent. So I'm going to write log base 3 of 4 is equal to is equal to log base 3 of x squared. Now I have a common log that is the same to both of them. It's not the common log, but common to both of these. And therefore, my arguments must be equal to each other. So I've got 4 is equal to x squared. Now, in this particular problem, remember, the domain is that x has to be a positive number, and that's going to happen everywhere except for when x is 0. If we get x is 0, then our answer will not work. But we're going to set this problem up where the original problem was just log base 3 of x, and therefore we're going to say our x has to be positive. Let's take the square root of both sides. We've got the square root of 4 and the square root of x squared. The square root of x squared equals x, but the square root of 4 is plus or minus 2. Now understand that if I type in 2 log base 3 of negative 2, we're going to have a problem. So I'm going to state right here that x equals 2 is the only answer that can make this a true statement. And let me show you how that happens. I happen to store x in my calculator as negative 2. When I type in 2 log base 3 of negative 2, it says that it's an error. Even though we know that x squared, when we throw it up here, would be all real numbers except when x is 0, the original problem just had x. And therefore, our restriction is that x has to be positive. Okay, let's take a look at this. Now on problem 2, I want you to notice that there are 2 logarithms that are added together. And we're going to need to simplify that down into 1. Remember back to section 5.5 when we used the sum, turning it into a product of the 2 arguments. I can rewrite this as log base 2 of the product of x plus 2 times 1 minus x. And that equals 1. Now the problem here is, even though I have a single term, there's not a log on both sides. So I'm not going to be able to solve this using that common log bases property from before. But we are going to look at this problem here. I can multiply those together and write this as 2 to the first equals x plus 2 times 1 minus x. When I multiply that out using box method or FOIL or whatever you want, I get 2 equals x, negative x squared minus x plus 2. So I've got negative x squared minus x plus 2. I'm going to subtract 2 from both sides because it's a quadratic, and I get 0 equals negative x squared minus x. That canceled as well. Now when I factor, when I'm solving this, I don't factor using the box method. I just factor pulling out the greatest common factor. So I'm going to pull out a negative x, and that's going to leave me with x plus 1. So x could be 0 from the first one, or x could equal negative 1 from this factor. Because remember we said negative x equals 0, so x is 0, and x plus 1 equals 0, so x could be negative 1. Now let's go back and look at our original domain. This particular problem, remember, this has to be positive, so x has to be greater than negative 2. Both of those are greater than negative 2, so we're doing great so far. On this one, x is going to have to come out being less than 1. Both of my answers are also less than 1. That means both of these answers make the problem true. Remember that we had a property said that if it was an exponent form, if the bases were equal, then the exponents are equal as well. Well, I got to tell you that using that property for this problem is a little bit useless because 7 is not a power of 3. I can't rewrite 7 as any property of 3 that I know, at least not off the top of my head. But I have two options. The first of which is to rewrite this as a log. So I'm going to roll it. And when I roll this problem, I'm going to say log base 3, because there's the base, of 7 is equal to x. Well, I just oscillated x. That is the answer. But if I'm typing this into the computer, it's probably not going to let me type in log base 3 of 7. So they're going to want me to rewrite it as the natural log of 7 divided by the natural log of 3, or the common log of 7 divided by the common log of 3. Either one of those answers are all correct, but make sure when you're putting it into the computer program that you either use common log of 7 divided by common log of 3, natural log of 7 divided by the natural log of 3, or common log of 7 divided by the common log of 3. We've got one more example problem that I want to show you on this video, and that's this problem right here. This is not an exponent form in simplified exponent form or in log form. So to get it to in simplified exponent form, I'm going to divide both sides by 5. 5 divided by 5 cancels, so that's 2 to the x equals 3/5. Once again, x is a value that I don't know, and I can't rewrite this as a base of 2, at least not very easily, so I'm going to roll it. I'm going to write log base 2 of 3/5 is equal to x. Now I've isolated, that's the answer, it's the exact answer, but what if they wanted me to write it in terms of natural log or common log? Then I would write natural log of 3/5 divided by the natural log of 2, or common log of 3/5 divided by the common log of 2. Now we are going to skip example 5. I'm not going to give you one like that on the test or on any quizzes. I don't believe you have any in the homework as well, so we're just going to skip that entirely. This problem right here could actually show up in a test, a quiz, and it does show up in your homework. Recognize that I would like anything with an exponent to have the same base, and I'm going to start off by rewriting that as 3 squared to the x power makes it 3 to the 2x minus 3 to the x minus 6 equals 0. Now we don't need to worry about that one because the exponent is not x. What if I looked at this and I told you I kind of see a quadratic in there? But the way I'm going to see the quadratic is I am going to change 3 to the x for the letter w. Remember when we had cosine squared, we had 4 cosine squared of x, and I told you you could replace cosine of x with just the letter x or w so that you could rewrite that as 4w squared? Well, we're going to do the same thing. We're going to change 3 to the x and replace it with the letter w. So if I take 3 to the x here and I replace it with the letter w, do you notice there's still a squared? Because 3 to the x became w, but there's still a squared right there. Minus 3 to the x, which I'm going to replace with w, minus 6 equals 0. Now I have a quadratic. And I have a quadratic that I can simply factor. W minus 3 times W plus 2. Remember factoring. Just go back and practice that. Which means that W could be 3 or W could equal negative 2. But I have not solved the problem. I solved for W. I didn't solve for X. X was in the original problem. So now we're going to change back. We're going to change W back for 3 to the X. So right here where it said W, I'm going to write 3 to the X equals 3. And I'm going to write 3 to the X equals negative 2. So now I have two problems I'm solving. Well, there's 3 to the X equals 3 to the first. X equals 1. All right, that's an answer. I can't make them the same bases, at least not easily, so I'm going to rewrite log base 3 of negative 2 equals X. Remember back, though, that my domain says that the argument has to be positive. Is that a positive number? It's not. So this will not work. That's called an extraneous solution. This solution would not make the problem true. So X equals 1 is the solution to our problem. Section 5.6 is really just about practicing all of the different properties and the manipulations that we've done with logarithms and exponents and bringing it all together into solving. This last problem right here, I'm going to expect you to be able to do using your calculator in one way only. We're not going to actually do any manipulation. We're going to set y sub 1 on your graphing calculator equals x plus e to the x power. We're going to set y sub 2 equal to 2. You're going to graph it, and then you're going to calculate the intersection to find the answer to 3 decimal places. Y sub 1, type this in. Y sub 2, type in 2. Calculate the intersection. Good luck with your homework. Ask me any questions if you got them.